Yes,
or
ma'am.
no?
Yes, ma'am.
Everybody will install the Oracle that I have sent in your machine, okay? Today also I will show you in the last part, I will show you some little bit about SQL. Okay, let's start again. So attribute closure is clear with you, isn't it? So this is one of the method. The first method was closure, but closure is a tedious job because every axioms we have to apply and it's we might miss some. So attribute closure is much better method. Another method is which is known as the reduction method. The reduction method. In the reduction method, what we do, we first of all write all the attributes of the relation. So SID, PID, then we have city, status, quantity. We write all the attributes. After writing the attributes, my what I will try is I will try to reduce this set. This is a set of all the attributes. I will try to reduce the set. How I will try to reduce the set? I will start with the first FD. Let me write the FDs again. Let me write the FDs again. So I will, you have to maintain the order, okay? Now suppose this is, I start with the first one, this is 1, then I follow the second one, then I follow the third one. So 1, 2, 3 is my order for the first time. So I get SID is part of this, hence I remove city, I reduce city or I remove city from the set. Next. City is again, it has been removed, so it is no more a part of this one. So I don't have to, I cannot do anything. SID PID is a part of this set, hence I remove quantity. Remove quantity from the set. When I remove quantity from the set, this is which I don't have to do anything. So this is which order? Order 1, 2, 3. This is the order. Next, what is the second order? Second order can be 3, 2, 1. This can be another order. So what I will do, I will write all the attributes of the relation. I will write all the attributes of the relation. Let me find this one. SID, PID, and start. What is the order I'm following now? 3 first, then 2, then 1. So SID, PID determines quantity. SID, PID is there. So I will remove quantity from here. Next, city to status. City is there. So I will remove status from here. Next, I have SID. SID is part of this, so I will remove city. So what I'm getting? Each, whatever in these orders, whatever I'm getting is a super key. Again, here, whatever I'm getting is a super key. Next, let us follow another order. Let the order be 2, 1, 3. 2, 1, 3. So in 2, 1, 3, what I will do, again, I will write all the attributes of the relation and try to reduce it 1 by 1 according to the order of the FDs. So 2, 3, 1. 2 is city to status. City to status. So I will remove status from here. Next I have 2, then 1, SID. SID is there, so I will remove city. Next, SID, PID. SID, PID is there, so I will remove quantity. So 213 is also giving me the same combination. So this is another SK, super key. What is the third combination? All of you find out the other combinations and tell me.
231.
231, what it is, what we are getting finally? What we are getting in the final answer? What happened?
Miss ID, PID.
Again, SID, PID. Any other combination? So what I'm getting is, whatever possible combinations you will do, you will ultimately see that these are the super keys. From these super keys, one by one, you have to find out which one is minimal. Now here, SID, PID status is obviously not minimal because one of the subset SID, PID combinedly is a super key again, isn't it? We can see from here. See, I never got SID. I never in any combination. I'm not getting SID or PID. So this is minimal. So yes. Similarly, other also. So what is the candidate key? I'm getting SID, PID candidate key. Here. So what I did, I wrote all the attributes of the relation. I order wise means 1, 2, 3, then 3, 2, 1. This way I did all possible combinations. For each combination, I found out whatever I got are the super keys. Each is a super key. Now from those super keys, I will find out who are the minimals and those will become your candidate key. Is it clear? The three methods? Any one method can, whichever is easier for you, whichever you find easier, you will adopt that, you will use that method, okay? Next. What is next? From the set of candidate keys, what I do, I select anyone as the primary key of the relation. Now, let us come back to the table. Till this, is it clear to everyone? Finding out candidate key?
Yes, ma'am.
Everybody is listening or the timing is so bad for this class? Feeling sleepy? All of you had your lunch?
Yes, ma'am.
Yes, ma'am.
Don't respond.
Yes, ma'am.
Yes, yes, ma'am.
Everybody had your lunch?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now let us come back to the table. Let me remove this one. What is the problem in the table? I have added only few rows. Imagine that there are many rows in the table. Okay. Now what is the problem? Can anybody identify the problem present in this table? Tell me fast. What is the problem present in this table? Or is there any problem or no problem is there? Suppose I'm adding few more records. This one, supplying product P3. P3 stays in Kolkata. Stays in Kolkata. Status of Kolkata is K1 and the quantity is suppose 10. Tell me, what is the problem?
Ma'am, it has repeated values.
Hmm?
Ma'am, the values are repeated in every tuple.
Which values?
Ma'am, the values of SID, PID, city, status, all the values are repeated.
Any other answer?
Yes, ma'am. For a different PID value, we have to repeat the values in city, status, and quantity, and SID. That means for
SID.
one value,
I will not
for
repeat. I will not write if S1 supplies product P4 and S1 also supplies product P5. I have to write S1, isn't it? Whom I will
yes,
write
ma'am.
here? Whose ID I will
But
write here?
but for that we have to repeat some data like city and status repeatedly.
Which data? That is the question. Which data is redundantly, which is not required, but I am repeating. I have to repeat, in other words.
Yes, ma'am.
Which
There
data? See,
is
this
city and
data,
status.
let me tell you, supplier ID has to be repeated, because if supplier S1 supplies 100 products, then everywhere I have to write S1 supplies P1, S1 supplies P2, S1 supplies P3. This way I have to repeat 100 times. I cannot leave it blank. It has no meaning if I leave this part blank. Who is the supplier who's supplying P1? Isn't it? So I have to repeat this. Now, come to product. In the product, P1 has been supplied by S1. P1 is also supplied by S2. But that is not a redundant information. It is an important, I cannot ignore that information. If I leave it blank, then what is S2 supplying? S2 is supplying P1. So it is a meaningful information I am keeping in my table. Next, city. Come to city. S1 stays in Kolkata. From which row did I understand that S1 stays in Kolkata? If I write a query, if I write select, I don't know whether I said you about select clause or not. If I write select the city, find out the city where S1 stays. And if I only write it in the first row, I write S1 stays in Kolkata. Then was it necessary to repeat everywhere that S1 stays in Kolkata, S1 stays in Kolkata, S1 stays in Kolkata? If 100 places are having S1 Kolkata, then in 100 such tuples, I am repeating S1 stays in Kolkata. This is a redundant information I am keeping in my table. From the very first row, it was clear that S1 stays in Kolkata. Again, S2, suppose S2 supplies 100 products. From this row itself, it is clear that S2 stays in Delhi. But still, I'm repeating, wherever S2 is there, I'm repeating Delhi, Delhi, Delhi. I cannot keep it null. Next, status. From the very first row of this row, it was clear to all of us that the status of Kolkata is K1. But everywhere, wherever Kolkata is repeated, I am writing K1, 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 K1. This is a redundantly, I am storing the status in my table. Redundantly, I am storing the city of S1 in those tuples. Quantities, all right, because I require the quantity. How much quantity it is? Here 10, 10, 10 is not redundant, because 10 means how much by how much quantity P1 has been supplied by S1, by how much quantity P1 has been supplied by S2. So quantity 10, 10 can be repeated. It is a meaningful information. If it is 10, several suppliers supplies by 10 units, then we have to write it. But the redundant information that we have kept here was the status of Kolkata was K1. Everywhere I repeated, and supplier S1 stays in Kolkata, or supplier S2 stays in Delhi. These are the things that are repeated many times. Why it is repeated? Because there is a dependency, isn't it? Why it is repeated every time? Why not? I cannot write here S1 Kolkata, then S1 Delhi. I cannot write that, because city is dependent on SID. Status is dependent on city. So these dependencies are there, hence they are redundant. This is known as redundancy. So redundancy is what? Redundancy means any unnecessary data kept in your table is known as redundant data. So redundantly, which is unnecessary. Simply we have kept it here due to those dependencies. Since those dependencies are there, we have to keep it in this manner. So it is a lot of redundancy is there in the table. This is the problem in this table. Clear? Is it clear? So never say that, ma'am, P1 is repeated. That's why it is redundant. No, it is not redundant. PID is not redundant. SID information is also not redundant. Quantity is also not redundant. Okay. Understood? Understood what is redundancy?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So this table now, what is the solution? What we have to do if there are lots of redundancy? What is the problem? You have to first of all know why we cannot keep redundant information. Why unnecessary information? We can keep it, no problem. We will store it in this manner. No, the reason is redundancy. First of all that comes into our mind is due to redundancy, space is required. Memory will be wasted. Unnecessary information if I keep in my memory, it is what? Wastage of memory. Memory is short, isn't it? We should utilize our memory. This is the first point. What is the second important point? Another important point is due to redundancy. Redundancy leads to certain anomalies. Redundancy leads to certain anomalies. What is the anomalies that that arises due to this redundancy? The anomalies are update anomalies. Second one is delete anomaly or deletion anomaly. Delete anomaly. The third one is insertion anomaly or insert anomaly. Okay. So these are the anomalies that will be present in your table if you keep lot of redundancies are there in your table. So the full normalization chapter tries to reduce the redundancy. Okay, it cannot remove it totally, but it tries to remove the redundancy as far as possible. Now, what is this update anomaly? Let us come to the anomalies one by one. Suppose there is a person. Before telling the example, the anomalies means when I say update anomaly, delete anomaly, insert anomaly, in one sentence I can say, if there are anomalies, if these anomalies are there, then there will be more insertion, more deletion, more updation. If redundancy is there, it leads to anomalies, and these anomalies, suppose there is updation anomaly. Updation anomaly means more updation has to take place. Deletion anomaly means more deletion will take place, and insert means more insertion will take place. What is the meaning of all these? More insert, more update, more delete. What is the meaning? The meaning is, let me one by one tell you the examples. Update. Suppose there is suppose supplier S1 used to stay in Kolkata. Now the city, he has shifted to some other city, and the city of S1 is now Mumbai. Don't write Mumbai. Let me give another. Suppose Ranchi. Okay. S1 has shifted to Ranchi, from Kolkata to Ranchi. So what we have to do? Can I keep this information in my table? Can I keep S1 P1 Ranchi, then S1 P2 Kolkata, then again S1 P3 Kolkata, S1 P4 Kolkata, S1 P5 Kolkata? Can I do this? Can I keep this? No, I cannot keep such information in my table. This, if I keep, then it is known as inconsistent data. This is a term that I will use many times. Inconsistent data. Logically, it is incorrect. Inconsistent data. What is the inconsistency? Suppose if I am writing a query, where does the supplier S1 stay? You cannot say that the supplier response stays in Ranchi, Kolkata, this. No, at a particular instance, a supplier stays in a single city. It was given in your problem. So I cannot write for the same SID, and since there is a dependency, SID determines city. So I have to go and update everywhere, wherever Kolkata is there associated with S1, I have to go and update it. So more updation we are doing due to redundancy. Now the thing is, suppose while updation, I'm continuously updating. A program is updating, isn't it? Manually, we are not going to, or manually also sometimes we update, we write update query, then we go there, and this way we do. So while updation, it might happen that suppose there are 100 records that I have to update. Out of those 100 records, 10 updation is over, I have committed 10 updation, but the remaining rows, some failure occurred. I could not update the remaining rows. So what happens at a particular instance, or even if no failure happens, I forgot. By mistake, I did not update the other records. So what happens? Due to this redundancy, more updation is required because it leads to updation. This is the updation anomaly. So it might happen that some records got successfully updated, other records which needed to be updated did not get modified. So ultimately, we are getting a table at a particular instance where inconsistency is present in your data. No inconsistency, RDBMS doesn't allow any inconsistency in your data set. Okay. So what I have to do, I have to do more updations. So let me remove this again. Let it be that. Take Kolkata. This is understood. Next, deletion. What is deletion saying? Suppose here, who is the candidate key? SID PID is the candidate key. Now, what is, suppose since there is a single candidate key, who will be the primary key? That same attribute, set of attributes will be the primary key. So, who is the primary key of this table? SID PID is the primary key of this table. Now, what is the feature of primary key? Primary key says that it has to be unique and it has to be not null. When it is a combination attribute acting as a primary key means that individually the column can have duplicate values, but combination has to be unique. This is the thing. But neither SID can be null nor PID can be null. Isn't it? This was the concept of composite primary key. All of you understood what I said? This is a composite primary key present in our table. This is a composite primary key present in our table. So their combination has to be unique. Their combination has to be unique. But individually means each attribute. Individually, neither SID can be null, nor PID can be null. This is the feature. Now, the thing is, suppose I was talking about deletion anomalies. Suppose I found that S2 is a supplier. S2 is a supplier. Temporarily, due to some problem, S2 stopped supplying the product P1. Okay. 1 minute. So what I said, S2 is a supplier, has stopped temporarily due to some problem. S2 stopped supplying the product P1. So what I will do, I will remove S2's information regarding the product and the quantity from the table, isn't it? S2 is not supplying P1 temporarily, and S2, the quantity also has to be removed. Can I do this? No, I cannot remove single values from here. I cannot do that. Moreover, I cannot keep this PID value null because it is a combination primary key of this particular table. So I cannot keep this also null. So what I have to do, I have to delete in order to remove only the product information. I wanted only to remove the product information and the quantity information because the supplier is not supplying any product for the time being. But in order to do that, since everything is kept in the same table redundantly, so what we have to do is we have to delete the full row. When I'm deleting the full record from here, so along with the product and the quantity, what else I am deleting? I'm deleting the information about where does the supply used to stay or where does the supply stays and what is the status of Delhi, that also I am removing. So I'm using more data, I'm doing more deletion. Hence, I have to remove it totally. Okay. Similarly, for insertion, suppose there is a supplier, a new supplier entered into this supplier system or this table, some new record, some new supplier has arrived. Okay, let the supplier be S7. S7 is a supplier and stays in Durgapur. The supplier for the time being is not supplying any product because he or she is a very new supplier and the management did not that this am I audible? I only want the information that where this new supplier stays and what is the status of that city I want to insert in this table, but I will be unable to do that. I have to do more insertion until and unless the supplier is assigned a product. I cannot insert this record. I cannot keep this null. Okay. So what I have to do, I have to do more insertion. All these are happening due to the redundancy. Every attribute, every columns are present in a single table. So a good database design says that you should not keep everything in a single table. You should decompose the table into different small parts in order to remove redundancy. So our target from now onwards will be to decompose the table. How we will decompose, what will be the advantage, all these we will study in normalization. What is this normalization? Normalization means in order to remove redundancy, since redundancy leads to all these problems, so in order to remove, we should try to remove redundancy from a table as far as possible. In order to remove the redundancy, we do decompose the table into parts, into subparts, and this decomposition overall is known as normalization procedure. Okay. Is it clear till whatever I said? Yes or no?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Any doubt? I will stop sharing and I will end the meeting, again rejoin. Let's start again. In this functional dependencies, I haven't said you about this canonical power. I will tell you that. But before that, let me start with normalization. I will tell canonical power after that. Normalization. Normalization. I just now said what is this normalization? What we will do. Now it is first of all divided into some groups, we can say, or some types, we can say. We say it is 1NF, one normal form. Then there is 2 normal form, 2NF. Then we have 3 normal form. Then we have 4 normal form. And we also have 5 NF. So we will study all these one by one. One normal form, I will tell you the definition. You will write the definition, then you will understand what it is, and we will solve problems also. So now if I do the diagram, all of you do it in your copy, otherwise it will take time. First of all, you all draw a box and then write, after 3NF, you also add BCNF. BCNF, then write 4NF, then 5NF. So first you write one normal form in a box. Then you do an outer box covering that inner box and then write 2NF. Then you do a third box covering the previous 2. Write 3NF. Then do a fourth one covering the previous ones. Write BCNF. Then another box, 4NF, and the last one is 5NF. What is the meaning of, did everybody did this? What is the meaning? The meaning is, if I'm in 2NF, then I'm already in 1NF. If I means what? The relation. If the relation is in 3NF, then it is already in 2NF, and if it is in 2NF, that means it is also in 1NF. If I'm in BCNF, I means the relation. If the relation is in BCNF, then it is already in 3NF, it is already in 2NF, it is already in 1NF. All these we will know one by one. So just the diagram, you will understand the diagram once we do all the normal forms. Now, in RDBMS, a relation is always in 1NF. Whatever relation I have designed here, it is in 1NF. What does 1NF say? First normal form says that a relation, just write, a relation is in 1NF if the relation is in, see, this is not a very formal definition. I'm not making you write formal definitions. You can get it obviously from the book. This is a very informal one, and only for your understanding, I'm making you write. So don't write these definitions in the exam. In the exam, you will just read from the book the formal definitions and then you write, if at all it comes. So 1NF means, just understand first of all, 1NF means every cell here should have logically individual values, or every cell should have logically inseparable values. Every cell should have logically inseparable values. What is the meaning of this one? Just understand the meaning. See, supplier S1 supplies how many products? P1, P3, P4, P5. So I cannot write in this manner. P1, P4, comma, P5, and other values. I cannot assign a value. So these are logically separable, isn't it? Product P1 is different from product P2. Product P2 is different from product P1. So I can, my application, whatever application or programs I write, I can distinguish between product P1, product P4, product P5. So they are separate values. Those separate values, I cannot keep it in a single cell of a particular tuple. Okay, so I have to keep it separately. Now the question is, some of you might ask me that, ma'am, here in the status column you have written DD1. Is it not separable? D is separate, another D is also a separate character. 1 is a separate character, Dhanbad, DHA, and so many characters we are writing one after another. But I will say no, it is logically a single value. Kolkata is logically a single value. It is not separable. I cannot say K1, O is another, L is another. No, it is logically, when I ask what is the city of supplier S1, you will say Kolkata as a single individual value, which is logically inseparable. Similarly, K1, M1, DD1, these are what? These are also multiple characters are there, but it is again logically inseparable. DD1 is a single individual value. What value? Status value. Quantity 10, 14, 15. This is also a single individual value. Again, if I add address, suppose instead of Kolkata, I'm adding, instead of city, I'm changing this and I'm writing Kolkata, Jodhpur, and other pin or 7 lakh, something like this, 7 lakh, 6, 7, 8. Okay, so this is an address. Similarly, in other cell also, I can add an address. Now you might ask me, ma'am, again here you have given a comma, and then you have written so many words, Kolkata, Jodhpur, then again a pin number. These are all separate values, isn't it? Yes, it is separate values. But whether it is separate or whether it is atomic, a single value, it depends on the applications that comes to your database or to this table. Now, what is the meaning? Suppose if I say, what is the address of the supplier S1? Then what you will say? You will retrieve Kolkata, comma, Jodhpur Gardens, comma, or Jodhpur Park, comma, 7 lakh, 6, 7, 8. The full thing is the address. It is a logically inseparable. But I ask you, what is the city of S1? Then you will say, Sunny Kumar.
Yes, ma'am, by mistake, sorry.
By mistake.
Yes, ma'am.
So you're getting bored or what?
No, ma'am. Just clicked.
Just clicked. Just click कैसे हो जाता है? Yeah, I could have disable the annotation. I thought you all are grown up. You will not do all these things. That's why I did not disable the annotation for all of you. Okay, anyway. Now, once you did this, I won't be able to remove it and I have to carry on with this. This is the problem. So don't behave like a child. Now, what I was saying is, if I ask you that, if your application or your query says, find out the city of S1, then you will say it is Kolkata. That means you are storing several things together. You can identify Kolkata as a different object or a different data, a different piece of data, isn't it? City is Kolkata. So here you have kept so many things together. So it always depends on the application, whether your application identifies your data as a single unit or together it can be considered as a single unit. If you identify city as a different data, then you cannot keep everything in the same. Then you have to make a city column, you have to make a pin column, you have to make a street column. But if you only find out the address of S1, then you could have kept all these together. So then it will be considered, if you if your application wants address information from S1 or any other supplier, then it is atomic value. Atomic means logically inseparable value. But what, like this one is also atomic. This is also atomic. So all these values are atomic, logically inseparable values. But if your application wants city as a different value, then don't keep it address. Keep city. Make a different column for location, area, region, pin, all these things. You can make different columns. Okay. So 1NF says that every cell should have atomic values, values which are logically inseparable. By giving comma and writing all the products in a single cell is not allowed. So in RDBMS, whatever tables we create are, we always consider that it is in 1NF. Or you rather check the, maybe there is some student who have entered many, giving a comma, they have entered many products together. Then you have to change it. Okay. So this is 1NF. Now what is this 2NF? Let us come to 2NF. What does 2NF says? Say 2NF says, just write the definition. Relation is in 2NF. We will write it. Give the heading second normal form. 2NF. A relation is in, write it, all of you. A relation is in 2NF if it is already in 1NF. A relation is in 2NF if it is already in 1NF. And no non-key attribute is partially dependent on the candidate key. A relation is in 2NF if it is already in 1NF, and no non-key attribute is partially dependent on the candidate key. No non-key attribute is partially dependent on the candidate key. Written? Now, what is the meaning? We will understand. So first of all, if a relation, now suppose if a relation is given to you, I might ask you that find out whether this relation is in 2NF or not. What you will do then? First of all, you will find out whether it is in 1NF or not. You will check the data. If data is given, if data is not given, you will say we assume that in RDBMS it is already in 1NF. And if data is given to you, you will check the data. Next, you will find out the second point. What is the second point? The second point is no non-key attribute should partially depend on the candidate key. Very important to understand. Listen carefully. First of all, tell me, who is the candidate key of this relation? Who is the candidate key?
SID, PID.
SID, PID. Now, whoever are the parts of this candidate key. So this is a candidate key CK. Here, SID is a part of this candidate key. So SID is known as a key attribute. SID is a key attribute. In some books, this key attribute is also known as a prime attribute. So SID is a prime attribute or key attribute. And similarly, PID is another part of the candidate key. So PID is also another key attribute. Key attribute or prime attribute. Clear? Then who are the non-key attributes or non-prime attributes? The remaining attributes who doesn't take part in the formation of candidate key are the non-prime or non-key attributes. Okay. So who are the non-key attributes of this relation? SID, PID. Next, city, comma. Sunny Kumar, tell me, what are the other non-key attributes of this relation? What are the other non-key attributes of this relation? Sunny Kumar. Kumar, isn't it your surname? I don't know. I have another student in another year, Sunny Kumar. So I'm saying Sunny Kumar. I don't know what is your surname. Is there or not? Sunny Kumar is not there, most probably. Let me check. Oh, find the participants. Yes, Sunny Kumar is there. Sunny Kumar, tell me, what will be the other non-key attributes? You are there or gone? Sunny Kumar is not there. Just see. He came and annotated, and then he is not there. Let me remove him. Oh, you annotate for it. My daughter is laughing seeing the annotation. Wait, let me remove Sunny Kumar. Okay. Any other student can tell me? What are the non-key attributes?
SID.
Anyone else can help me in this one? What are the non-key attributes?
Status,
Ma'am, quantity.
ma'am, quantity and status.
Quantity. So PID, city, status, quantity are the non-key attributes. Non-key attributes. Now what we will do, what is the definition saying? No non-key attribute should partially dependent on the candidate, should partially depend on the candidate. Candidate key SID, PID. So what you have to do is, you have to go and check your FDs. These are your FDs. These are the 3 FDs. So city is a non-key attribute. Is the non-key attribute dependent on a part of a candidate key? Partially dependent means the non-key attribute on the right-hand side should not depend on a part of the candidate key. If it depends on a part of the, or in other words, the non-key attributes on the right-hand side should not depend on a key attribute. Who is a key
Excuse me,
attribute? A
ma'am.
part of the candidate key.
Ma'am, how is PID non-key attribute?
Sorry, I wrote PID. Sorry, very sorry. City, status, quantity are the non-key attributes. Now, here, there is, yes. So non-key attribute city is dependent on a part of the candidate key. So it is what type of, does 2NF allow that? No, 2NF says that no non-key attribute should partially depend on the candidate key. Partially means should not depend on a part of the candidate key. Or in other words, no non-key attribute should not depend on a key attribute, but it is there. Moreover, let me go to the next one. Status is a non-key attribute. Does it depend on a part of the candidate key? No. City is also a non-key. Status is also a non-key. So this is all right. Then go to SID, PID, quantity. Quantity is obviously a non-key attribute, but quantity is dependent on the full candidate key, not a part. So we will say, now we will categorize functional dependency as FFD. This is nothing, and this one is PD. What is PD? This is a kind of FD which is known as partial dependency, and this is a kind of FD which is known as fully functional dependent. Fully functional dependent. So quantity is the non-key attributes. It is dependent on the full candidate key. So it is a FFD. So no PD is allowed into NF. Okay. But city to status is what? Non-key, non-key. Non-key on the left-hand side and non-key on the right-hand side. Non-key and non-key, no, nothing has been mentioned in 2NF. 2NF doesn't worry about non-key depending on a non-key. It doesn't worry, it not say anything. It only doesn't allow non-key dependent on a key attribute. Clear? So this relation is not in 2NF because there is a partial dependency present in your table. What you will say? This relation is not into NF because there is a partial dependency present in the table. Understood? Till this, is it clear? So what I have to do? Since it is not into NF, in order to remove redundancy, my target will be to convert the table to its higher normal form. Always we will try to convert the tables. How I will convert? By breaking the table into two parts. I will show you that. Now, the objective is to convert the table to higher normal form. So I just now found the table I had taken as an example was in 1NF, but it is not in 2NF. So we have to convert the table to its second normal form. Till this, is it clear? Then I will proceed if it is clear. If you are listening, then it will be clear. Otherwise, it won't. Is it clear?
Ma'am,
Yes.
ma'am,
Yes, tell me.
according to the given definition of 2NF,
See, your voice is cracking. Tell me once more.
hello,
Tell me once more.
is it audible?
Is
Ma'am, I am saying that according to the 2NF definition,
yes. According to the
according to the
definition,
2NF definition, that CID is CID means city is actually dependent on the means partially dependent on the candidate key. City SID.
I'm
So
not getting, your voice is
it comes
cracking.
under the category of 2NF.
CP is a non-key attribute which is dependent on the key attribute, isn't it? Because just now we saw that SID is a key attribute. Now, this is a partial dependency. So we don't allow partial dependency in 2NF. 2NF says that no non-key attribute should partially depend on the candidate key. Partially depending on the candidate key means depending on a part of the candidate key. Okay. Any doubt? So let me proceed. Now what I have to do, if it is not in 2NF, what I have to do? I have to decompose the table. How I will decompose the table? I will first of all find out who is creating a problem. So here, the list of FDs, who was creating a problem? Why it is not in 2NF? Because SID was determining city and which was a partial dependency. Isn't it? Yes or no? Will I proceed?
Yes, ma'am.
Yes, ma'am.
Okay. So SID was dependent on, city was dependent on SID. So it was a partial dependency. This was creating a problem. Hence, I will have to remove that. Okay, how I will remove that? These two attributes, I have to make a separate table. So how I decompose, how I convert it into 2NF, I decompose the table into two tables. So how I will decompose that, I have to think. Okay, now the thing is, which attributes will belong to which table? See, SID PID determining quantity is a full functional dependency. It is not creating any problem. It is a full functional dependency. So let me keep it in one of the table, SID. Let me keep SID, PID, and which quantity? SID, PID, quantity in one of the table, and along with the data. Yep. And who was creating problem? SID, city to PID. So I will create another table. I will create another table. This is another table where I will keep, where I'm removing what? SID city, this one. This is creating a problem. So let me remove it from the original table. So SID city. Now what about another column is there? Which one? Status. Will I keep status here in this table? Let me name this table as T1 and this table as T2. Will I keep state? I cannot drop any column. Okay, every column has to be present either in this table or in that table. But I can have common columns. A column or more than one column can be repeated in the tables, broken tables, decomposed tables. Now, but status, where I will add status? Will I add status here or will I add status in this table? That is the question. Now, there are 2 points. While you suppose I am adding status here. I'm adding status here. So all attributes are added either here or there, and there is a common attribute SID. Okay. Now, once you decompose in your own manner, you will write who are the FDs present in each individual table. Here in this T1 table, I can write that SID PID determines quantity. Can I write? Because the previous FD, can I write it here? All the attributes are present. So the previous FD that was present in the original table, I can write it here. In this table, which FD I can write? SID to city. But what about city to status? Can I write city determines status? I cannot write because city is in this table, status is in that table. So I cannot write. I have lost one of the FD. What was the original FD? How many FDs were there? 3 FDs. SID to city, city to status, and SID PID to quantity. But city to status, I cannot get back in these FDs, in these tables, because status is in this table, city is in this table. So what I will do, I will not keep this status here. I will keep it here in this table. If I keep it here in this table, then I can also write city determines status. Now, next what you have to do is find out who is the candidate key of this relation and who is the candidate key of this relation. So who is the candidate key of T1? Can anybody tell me how I will find out the candidate key of T1? No one is listening properly.
SID PID.
SID PID, why?
Because its subset is not a super key. Any of this subset is not a super key.
Any of the subset is not, that is the reason for finding.
Ma'am, because SID PID determines the quantity and SID PID determines itself also. So it determines all the attributes.
Yes. So SID PID determines quantity. SID PID will obviously determine SID. SID PID will also determine PID because they are the reflexive trivial. So SID PID is a set which is determining all the attributes of the relation T1. Since SID PID is determining all the attributes of the relation T1, so SID PID is a super key. Now I have to find out whether it is minimal or not. It is minimal because neither SID is a super key, nor PID is a super key. Neither is, I have a FD with SID, nor I have an empty with PID. In other words, if I find out SID, PID, SID plus, if I find out SID plus, I only get SID. So it is not a super key. And if I do PID plus, I only get PID. But if I do SID, PID plus, you will get all the attributes, isn't it? So SID, PID is a minimal super key, hence it is the candidate. So let me color it. Combination, okay? So they together is a candidate key. Now come to the T2 table. In the T2 table, who is the candidate key? The T2 table, who is the candidate key?
SID, ma'am.
SID. Why?
Ma'am, because SID will determine all attributes. SID, city, and
SID is
status.
determining city
And status. And
uh,
city is determining status. So by transitivity,
okay, the
transitivity,
transitivity
SID.
rule, SID will also determine status. So SID is determining city and SID is determining status, and SID will determine itself. Hence, SID is an attribute which is determining all the attributes of the relation. So SID is a candidate key because it is a single attribute, no question of checking its subset. So SID is a candidate key of this relation. Let me make it yellow. SID is a candidate key of this relation. Okay. Now, there are 2 points. Whether this decomposition, the breaking of the original table is correct or not, I have decomposed it in my own manner, isn't it? But I have to check whether it is correct or not. In order to check whether the decomposition is correct or not, there are 2 rules. One of the rules is known as decomposition rule. Decomposition rule. And the other rule is known as what is the other rule? Wait, decomposition rule says that no lossy. Oh, I remember. Sometimes nowadays I'm forgetting. Dependency must be preserved. Dependency must be, which is known as dependency preservation rule. Preservation rule. 2 rules are there. One is decomposition rule, which is also known as no lossy, or just write, instead of writing this, you can write lossless decomposition should be there. Lossless decomposition. And the other one is dependency preservation. What is the first rule saying? The first rule is saying that if I join the 2, see, I have broken the original table into 2, isn't it? Now, when I join the 2 tables, if I join the 2 tables, I should get back the original table. No data should be lost, neither a data should be gained. I should not say data, I should say tuple. No new tuple should be added after joining, neither a tuple which was originally present in your table should be lost. So exactly whatever was there in your original table should be present in your decomposed table after joining. Understood? After joining, whatever data was there in your original table should be kept intact. Neither a loss nor a gain. Gain will also be known as a lossy decomposition. So no lossy decomposition should happen. It should be, the decomposition should be lossless. Now the thing is, how you will understand whether it is lossy or lossless. I'm stopping this because 40 minutes will be just over. Again, rejoin. So let's start. Do one thing, all of you write your roll number in the chat box. Last digit only. Everybody write your roll number in the chat box. Later on, if you write, I will not accept that. Only 43 students have written, others haven't. Okay, let me start. So what I was saying here is, whether the decomposition breaking is correct or not, we will check it via lossless decomposition rule and dependency preservation. Lossless decomposition says that when I join the two tables, I should get back exactly whatever data was present in your original table, the same set of data. I neither should gain a data nor should I lose anything. Now, how do I join two tables? When I have when I join the two tables, how do I join? The thing is, here there are many join operations. Actually, I say all the join operations in your practical class, but just know this, that suppose there are 4 tuples here in this T1 table, and there are 2 tuples there in the T2 table. Then in the join, we will have 4 into 2 number of products in the Cartesian product. So first of all, we don't join. What we do is, first of all, we form the Cartesian product or the cross product of the tables. What is the cross product of the table or Cartesian product? It is a combination of all tuples, all possible combinations. So what happens is, this row gets combined with this row. Again, first row of this one gets combined with the second row. Second row of this table gets combined with the first row. Again, second row of this one gets combined with the second row. Third row gets combined with first and then second, and fourth row again gets combined with first and second. So ultimately we get, after in the Cartesian product, we get 4 into 2. So 8 tuples. So if there are m number of rows in your T1 table and n number of rows in your T2 table, then we get, in the Cartesian product, we get m into n number of rows. Here, from the Cartesian product, we use the join condition and then we do the join. Now, these things we are going to do in the lab part, but joining two tables is a very tedious job again. So there is a shortcut method. Theoretically, what we will apply here is how we will understand whether the decomposed tables is lossy or lossless. The concept is, it will be lossless. It will be lossless. This is a trick I'm showing you. Okay, this is formally, when you will write it, you will write about join and then you will write this, whatever I'm showing you now. It will be lossless if the common, listen carefully, if the common attribute among the two tables or between the two tables, if the common attribute among the two tables is a candidate key of at least one of the relation. Is a candidate key of at least one of the relation. So what it is saying? When I can blindly say that yes, the decomposition is lossless, if I find that there is a common attribute. Who is the common attribute here? SID. The common attribute is a candidate key of at least this relation or that relation or both. So at least one of the relation, if the common attribute is a candidate key, then I can blindly say that the decomposition is lossless. Otherwise, it is lossy. So here, common attribute is SID and SID is a candidate key of T2 relation. Just now we saw it. Hence, the decomposition is perfectly all right. It is lossless. Understood? And what does dependency preservation say? Dependency preservation says that whatever FDs was present in the original table, all the FDs should be preserved in the decomposed table. See here, there were 3 FDs. So I got this FD here and I got these 2 FDs in this table. So ultimately all the 3 FDs are preserved in the decomposed tables. Now, sometimes it happens that directly you might not get the FD. So you will think that, ma'am, I have lost one of the FD or 2 FDs. No, you should not think so. You should think that after applying the axiom, suppose apparently you did not get it, but it might happen sometimes in some scenarios that after applying the axioms, you are getting back that FD. Even if that happens, that is also acceptable. So ultimately, you can see that whatever FDs are present in the F plus, here also, if in the F plus I get back all those FDs, or rather if applying axioms I can get back the FD, then also I will say the dependency is preserved. I don't know whether you're getting so many things I said today. Everybody should. Before that, now if these 2 rules are satisfied, then we will say the decomposition is all right. But after decomposition, we should check whether the relation has been converted to 2NF or not. That we will do not today, tomorrow. But before coming to class tomorrow, I will be asking you tomorrow questions from here, and you should go thoroughly. You should study whatever I said today. Otherwise, tomorrow's class will be total blank. Okay, please go through whatever I said. If you did not understand, you can ask your friend who understood, or you can also ask me, and then clarify it and come tomorrow. Don't just come for attendance, and don't just come for only sitting in the class. Okay, so let me save this, because I will continue with this tomorrow.